In this lesson video for day 1B.4, we are taking a look at parallel line angle relationship proofs again, but we're going to be doing less of the algebra and more of just the relationship proofs. So what we're going to do first is we're going to start off with just identifying some relationship angles. And so we're going to find an angle that satisfies each of the given conditions. So let's start with number 1. So we want to find an angle that is a corresponding angle to 4 and an alternate interior angle to 13. So I'm going to start with 4 here, and we've got these multiple lines drawn, and in these diagrams we have these two lines. I'll trace those for you. Okay. But we also have these other two lines. And any one of those lines could be a transversal because any one of those lines crosses two other lines. So if we're looking for corresponding angles to 4, there's actually two different angles that could be corresponding to 4. Angle 8 could be a corresponding angle to 4 because they're both to the right of line C, or kind of above line C, and they're both below each of these other two lines, A and B. But also, angle 12 is a corresponding angle to 4 because angle 4 and 12 are both below that blue line, below line A, but they're both kind of above and to the right, their individual pink lines C and D. So we have to figure out which one of those is also an alternate interior angle to 13. Well, angle 12 is an alternate interior angle to 13. So I am not going to use angle 8, I'm going to use angle 12. All right? So angle 12 is both corresponding to 4 and alternate interior to 13. Okay? So as we keep going through, the next one, consecutive interior angle to angle 3. Well, there's angle 3. There's only one other angle that could be a consecutive interior angle, and that is angle 5. Because angle 3 is an exterior angle for these two lines. It's outside of those two lines. So angle 5 is that answer. Excuse me. Number 3, we want a linear pair angle to 13. So if here's angle 13, 14 is a linear pair, and 15 is a linear pair with angle 13. But we want one that is alternate exterior to angle 7. So here's angle 7 over here. Well, alternate exterior to 7 would be 14. So angle 14 is both a linear pair with 13 and alternate exterior with 7. And so I want you to take some time and try and finish the rest of these, 4, 5, 6, 7, and 8. Pause the video and see if you can come up with what those are. When you're ready, you can click play to check your answers. These should be the answers you get for 4. So for angle 4, or number 4, linear pair to 13 and corresponding to 7 is angle 15. And for number 5, alternate exterior to angle 10 and vertical to angle 2 is angle 3. And for number 6, a linear pair to angle 2 and corresponding to 8 is angle 4. And for number 7, angle 5 is the one that is an alternate interior to angle 4 and alternate exterior to 16. And lastly, number 8, consecutive interior to 11 and alternate interior to 12 is angle 13. Okay? So as we move forward, we are working on proofs, and the given information is going to drastically reduce. We're not going to be given a lot else other than parallel lines, and we're just going to use angle relationships to help work our way through this. So as we begin number 1, all we're given is that that line M and line N are parallel. Remember, that means some very important things. I'm actually going to go back to the previous lesson and real quick and show you, if we have parallel lines, all the things that we can assume from that. Okay, so if we have parallel lines, all right, alternate interior angles are equal. They're congruent, they're equal to each other. Alternate exterior angles are also congruent or equal to each other. consecutive interior angles are supplementary, or they equal 180 when added together. Corresponding angles are also congruent. And then linear pair and vertical angles are also important also. Linear pair angles are supplementary. They add up to 180. And vertical angles are congruent. And so that's all very important information as we work through these proofs today. Ooh, there we go. So on number 1, we are given that M is parallel to N. So we're going to go ahead and start our proof with our given information. M is parallel to N. That's the only given I have. And what we want to do is look at what we're trying to prove and look at the information given in the picture and try and connect those two ideas. So we're supposed to prove that angles 2 and angles 3 are supplementary. Now, if you look at those, 2 and 3 are not any angle pair relationship we've talked about. They're not vertical. They're not linear pairs. They are not alternate interior. They're not alternate exterior. They're not consecutive interior. They're not corresponding. There is no angle relationship directly between 2 and 3, but we can still prove they're supplementary based on some other information. What I would do is look at a relationship of angles from the picture that are supplementary angles. And there's two different ways we can look at that, but the easiest thing to realize is that angles 1 and 3 form a linear pair. So they are supplementary. So what I can do next is say that the measure of angle, let me fix that. The measure of angle 1 plus the measure of angle 3 equals 180 degrees because they're a linear pair. Remember, linear pair angles are supplementary. Okay, but you will also notice we are given this angle in 2 and angle 3 to use as well. And if you look at the relationship between angle 2 and angle 3, angle 2 and angle 1, those are corresponding angles. We know corresponding angles are equal to each other because they're congruent. And so what I can do now is I can say the measure of angle 2 equals the measure of angle 1 because they are corresponding angles. Corresponding angles are congruent or have equal measure. Well, now I've got an equation here where I can actually substitute the measure of angle 2 in place of the measure of angle 1 because they're equal. So I can say the measure of angle 2 plus the measure of angle 3 has to then also equal 180 just by substitution. And since 2 and 3 add up to 180, that's what supplementary means. So I can say my final statement here that angle 2 and angle 3 are supplementary based on the meaning or definition of supplementary. And that finishes that proof. Okay? So let's continue on to some more examples. In example 2, a very similar proof to what we just did. In this one, we are given 2 parallel lines again, and these 3 marked angles, angles 1, 2, and 3. And we want to prove that 2 and 3 are supplementary again, but we're going to do that a little bit differently. Okay, we're going to start with our given information, M parallel to N. We always start with that given line, copy it down. Now we want to make that connection. Well, again, 2 and 3 are not directly related to each other. There is no angle pair that I can use for angles 2 and 3. But angle 2 is connected to angle 1. Those are consecutive interior angles, which are supplementary. And angle 3 is also connected to angle 1 because they're vertical angles. So they're the same. So we're going to do this very much like we just did the last proof. So the first thing we're going to do is say that the measure of angle 2 plus the measure of angle 1 equals 180 because consecutive interior angles are supplementary, but also the measure of angle 1 equals the measure of angle 3. That equal sign doesn't look very good. Because they're vertical angles. Vertical angles are congruent. So now, just like last time, I can substitute the measure of angle 3 in for the measure of angle 1 into that equation right there. Because we substituted, we get the equation measure of angle 2 plus measure of angle 3 equals 180. So I can say that these two angles are supplementary because that's what supplementary means. They add up to 180. Sorry, my pen's not working. There we go. Angle 2 and angle 3 are supplementary because of the definition or meaning of supplementary. Okay? And as we move on, this one is a little bit different. In this problem, we're given a picture a lot like we started the video with, where I have these multiple sets of intersecting lines, and these two lines are parallel. A and B are parallel, but also C and D are parallel. And so we get these angle relationships along both sets of parallel lines. And so as we work towards our proof, let's look at what we're trying to say. We want to prove that angles 4 and 13 are congruent to each other. Now here is the problem with that. 4 and 13 do not have anything in common. They don't share any sides. They are not along the same transversal. They do not fit any one angle pair relationship. So we are going to make we're going to chain a connection together of angle 4 connected to another angle that is also connected to angle 13. But I want them to be congruent angles. So I'm going to look at my congruent angle pair relationships. Okay, so either vertical angles or alternate interior angles or alternate exterior angles or corresponding angles. Okay? These pairs of angles always give you congruent angles when the lines are parallel. So what we want to do is be able to connect angle 4 to another angle that is congruent to 13, and we should have two options to pick from. Actually, several. So if I start with angle 4, what I'm going to do first is mark all the angles that are congruent to 4. 1 and 4 are congruent. Okay, 4 and 5 are congruent because they're alternate interior. Okay, 4 and 9 are congruent because they're alternate interior. 4 and 12 are congruent because they're corresponding. And then 4 and 8 are congruent because they're corresponding. Well, any one of those other angles other than angle 1 could be used as a congruent angle to 13. For example, angle 9 is a corresponding angle with 13. Angle 12 is an alternate interior angle with 13. So those are congruent. Or I come down here to the other intersection. Angle 5 and 13 are corresponding. Angle 5 and 8 are alternate interior. So we have a lot of options to choose from. We just need to pick one. So again, we're going to start our proof with the given. A is parallel to B. C is parallel to D. And that's given. Then we're going to connect angle 4 to another angle besides 13 that is congruent to 13 also. So I'm going to choose angle 9. I'm going to say angle 4 is congruent to angle 9 because those are alternate interior angles. And alternate interior angles are congruent when we have parallel lines. And then 9 is also congruent to 13. So I need to say that. Angle 9 is congruent to angle 13 because those are corresponding angles along that transversal D, and corresponding angles are congruent also. Well, now look at what we've done. We've said angle 4 is congruent to angle 9, which is also congruent to angle 13. So you might remember in a previous lesson we talked about something called the transitive property. If angle 4 is congruent to angle 9, and angle 9 is also congruent to angle 13, then we can link these together like this, that angle 9 is kind of that middle angle relationship. And so we can get rid of that middle angle relationship and say that angle 13 and 4 are congruent because they're congruent to the same angle 9. So I can say angle 4 is congruent to angle 13, which is what I was trying to prove, because of the transitive property. And that finishes that proof. And so your assignment will have different proofs involving these kind of shorter proofs, but they don't use as much algebra. So again, remember those angle relationships from the previous lessons, from 1B.2. They're going to be very important.